So next, applications of adsorption. So already I told that what is adsorption. So adsorption is the process in which the atoms or molecules of one substance gets attracted by the surface of another substance. It is a surface phenomena. So this adsorption phenomena is applied to different industrial purposes and academic purposes. First one, activated charcoal. So activated charcoal used as an adsorbent for the removal of toxic gases. For the removal of toxic gases by used for the purification of gases, and also removal of coloring matters present in this sugar solution, and also used for this activated charcoal to remove the coloring matter present in the effluents coming out from the dyeing industries. So this is the application of activated charcoal. Another is you can use for this alumina and silica gel that will reduce the humidity in the atmosphere. So atmospheric moisture having the water droplets spread out in the air. So that water droplets that should be absorbed towards the silica and alumina gel that should be used to reduce the humidity in the atmosphere for silica and alumina gels. And then heterogeneous catalysis. Heterogeneous catalysis is very much useful in the industrial process for the preparation of gases. For example, preparation of sulfur dioxide SO2 plus O2 the solid surface V2O5 solid will give SO3 gas. Here two gaseous molecules adsorbed in the solid surface vanadium pentoxide solid that will give the sulfur dioxide gas. So this is these two reactants adsorbed in the solid surface vanadium pentoxide solid surface. The reactions will be takes place in the solid surface. So this is the adsorption process. After this formation of the product in the solid surface vanadium pentoxide solid surface, we can remove or dissolve the product and get away from the vanadium pentoxide solid. So like this, many gases are prepared or synthesized by using the adsorption process by using heterogeneous catalysis method. So here this vanadium pentoxide solid is act as a catalyst. Like that, when you take this unsaturated hydrocarbons, oils is converted into fats. So unsaturated hydrocarbons is oils. It is converted into fats in the adsorbed in the nickel surface for hydrogenation reactions. It will converted into fats. So nickel is the solid. Here this hydrogenation reactions will be takes place in the nickel surface. Both the oils and hydrogen adsorbed in the nickel surface due to adsorption process is converted into fats. So this is also one of the application of adsorption. Here the rate of absorption will increases depends on the surface area of the nickel. So this is also an example of heterogeneous catalysis. The next application of adsorption is this Fuller's earth. The Fuller's earth is nothing but it is a hydrocarbon. It is used for the refining of petroleums. Refining of petroleum products. This by using this Fuller's earth by way of adsorption method, the crude oils that should be refined, that be converted into different petroleum products, separated by using this adsorption process. The adsorbent is Fuller's earth. It is used for the refining of petroleum products. Another application of adsorption is that is ion exchange resins. Ion exchange resins is used for the softening of hard waters. Softening of hard water. What is there are two types of ion exchange resin is there. One is cation exchange resin, another is anion exchange resin. Cation exchange resins will be used for the removal of cations present in the hard water. Anion exchange resins will be used for the removal of anions present in the hard water. So softening method, hard water is converted into soft water by the removal of carbonates, bicarbonates and chlorides, sulfates present in the water using the ion exchange resin by the method of adsorption. So hard water is converted into soft water by using the ion exchange resin by using adsorption method. Next application of adsorption process is fourth flotation process. Sulfide ores, that is lead sulfide, zinc sulfide, lead sulfide and copper sulfide can be purified by fourth flotation process, adsorption process. Sulfide ores, pure sulfide ores you can get using this fourth flotation process. The next application is arsenic poisoning. So when a person is taking arsenic, you can give this colloidal ferric hydroxide. This colloidal ferric hydroxide absorbed all the arsenic in the body. Then by way of vomiting, you can remove the arsenic from the body. So arsenic is a highly dangerous chemicals. It will create cancer in the lungs. So you can remove the arsenic poisoning using the adsorption process using colloidal ferric hydroxide as the adsorbent. And next, late test for Al3+. Aluminium Al3+ can be identified by using the litmus test. That is, Al3+ is converted into aluminium hydroxide. So Al3+ is converted into aluminium hydroxide. Then using this litmus test, you can identify the aluminium present in the compound. The next, mordants. So mordants used as an adsorbent in dyeing industries. Coloring matter present in the fabric can be adsorbed using the adsorption process by using mordants. Mordants as a adsorbent. So remove the removal of coloring matter present in the fabrics. The next one is production of high vacuum. High vacuum can be produced by connecting the charcoal or alumina chambers in the vacuum pumps. Next one is chromatographic analysis. Mixture of compounds in the organic chemistry. For example, you can prepare a compound. Compound is having A plus B plus C. Three compounds. Compound A and compound B and compound C. You can separate using the adsorption technique by A and B and C separately. That depends on the capacity of adsorption of A towards the adsorbent, absorption of B towards the adsorbent, absorption of C towards the adsorption. So chromatographic analysis, that is separation of mixture of compounds into individual compounds by using the adsorption method. Next one is evaporation of water. So water reservoirs and lakes spread out by the steric acid. The steric acid is dissolved, completely spread over the water reservoirs. That will not allow the water to evaporate due to sun heat. So due to that spreading of steric acid, the water in the reservoir as such is there for a long time. So that will not leave the water to evaporate due to sun heat above the due to atmosphere. So these are the different applications of 12 applications of adsorption process. So next topic is role of adsorbents. So adsorption process having two phases. One is adsorbent, another is adsorbate. Adsorbent is solid, adsorbate is whether liquid or gases, which is going to adsorb on the adsorbents. So the role of adsorption in catalytic reactions, heterogeneous catalysis reactions. It involves 4 steps. First one is action of heterogeneous catalysis. That is, first step is adsorption of reactant molecules. That is, nickel is the surface catalyst. It is a solid adsorbent, absorbs the hydrogen in this nickel solid surface having this ethylene and hydrogen. Both this hydrogen adsorbs on this ethylene, that gives ethane. So this nickel will adsorb the hydrogen, 2 hydrogen atoms. This is first step 1, that is adsorption of reactant molecules. Step 2 is formation of activated complex. So this after absorption, there is a formation of activated complex between these 2 hydrogen atoms and this nickel surface. So during this absorption process, heat is evolved. It is an exothermic reaction. Then step 3 is decomposition of activated complex. So formation of after this formation of activated complex, this activated complex gets decomposed. So these 2 hydrogen atoms having the permanent bond with this ethylene, and this gets cleaved. Then step 4 is desorption of the product. This ethane product formed in the solid surface nickel catalyst surface is dissolved, gets away from the solid surface. These are the 4 different steps which involved in the heterogeneous solid catalysis reactions. Another application of adsorbent is finally divided state of the catalyst. Finally divided state of the catalyst means the surface area should be clearly clear surface area and uniform surface area. For example, the nickel catalyst is uniformly packed and it's having the uniform surface area. It leads to more adsorption process. And second one is enhanced reactivity of the rough surface catalyst. When you increase the roughness of the surface of the adsorbent, the catalytic activity will be increased. For example, it creates peaks, cracks and corners. Peaks means it's having this highest nickel in the one side, and this is peak, and this is crack, and this is corners. So rough surface, when you're creating the rough surface above this solid adsorbent, that will leads to more adsorption process. The reaction will be takes place in the adsorbent surface is more, that will give you the more product. The yield should be more. So this is the second application of role of adsorption, and third one is action of promoters. So what is promoters? Promoters means promoter is a substance which increases the activity of the catalyst. For example, when you take this nickel catalyst, MO is the promoter that will go inside, occupy the inside the position of this nickel inside, that will increase the distance between the two nickel atoms. It will increase the distance between the two nickel atoms. Due to this increase in the distance between the two nickel atoms, the hydrogen bond length gets increased. Due to increase in the hydrogen bond length, this covalent bond gets cleaved very easily. The hydrogen atom will be easily adsorbed with this reactant molecules that will give the products. So that will also leads to increase the more surface area. So promoter will increase the catalytic activity of the catalyst. Then action of catalytic poisoning. What is catalytic poisoning? Catalytic poisoning is nothing but to kill the reactivity of the catalyst. For example, you take the platinum catalyst, when you adsorb with CO, that is carbon monoxide, that will have this bonds with this two platinum catalyst, that will destroy the activity of the catalyst of the platinum surface. So poisoning is nothing but destroyment of the activity of the catalyst, or to kill the activity of the catalyst. So this is the catalytic poisoning. Next one is specific action of the catalyst. Another important point of this adsorbent is specific. Sixth one is specific action of the catalyst. So what is meant by specific action of the catalyst means different adsorbate will need different type of adsorbent. For example, SO2 is converted into SO3. The adsorbent need is V2O5. Vanadium pentoxide gas, that is solid. Will give SO3 gas. So like that, different chemical reactions it needs different type of adsorption. So this is called specific action of the catalyst. So this is the different role of the adsorption for different chemical process. Next is applications of adsorption. So first one is role of adsorption and ion exchange adsorption. Ion exchange process is used to purify the water, that is mineral waters. That is nothing but softening of water. First process of what is ion exchange? Ion exchange is nothing but process of releasing the ion and absorbing the another like ion. For example, that is Na plus and H plus is replaced with Na plus and Ca2 plus and Mg2 plus. So cation exchanger is nothing but cations will be exchanged. Anion exchanger is nothing but anions will be exchanged. Resins, what is a cation exchanger? Resins containing, that is polymeric resins containing acidic functional groups. Acidic functional groups, for example, acidic functional group is nothing but carboxylic acid group COOH and sulfonic acid group SO3 group SO3H, etc. So that will exchange the H plus ion by using this, that will contain the exchange the H plus ion by Na plus and Ca2 plus and Mg2 plus ions. So that is cation exchanges will be represented by RH. So the H plus will be exchanged by Na plus, Ca2 plus and Mg2 plus. That is H plus from the acid functional group of this H or this H will be replaced with Na plus, Ca2 plus, Mg2 plus. So this is called cation exchanger. Example is cation exchanger. Example is styrene divinyl benzene copolymers. Styrene divinyl benzene copolymers containing sulfonic means SO3H. Sulfonic means SO3H and carboxylic acid means COOH groups. So this is an example for cation exchanger. Next, anion exchanger means that will exchange the anions, that is negative ions. So resins containing basic functional groups. Basic functional groups means, for example, amino functional groups, NH2 functional groups and OH minus ions, that is basic functional groups, OH minus and NH2 ions having this resins, polymeric resins, that will act as an anion exchanger. So that should be represented as or NO or N or 3OH, or maybe hydrogen or alkyl groups. Exchange OH minus ions, exchange Cl minus ions, SO4 2 minus ions, HCO3 minus ions, etc. So this OH will be replaced with Cl minus ion, SO4 2 minus ion and bicarbonate ion. So this is nothing but anion exchanger. Example for this anion exchanger is styrene divinyl benzene anion or amine formaldehyde copolymers. So both anion exchanger and cation exchanger, polymeric resins will be used for the anion and cation exchangers. Here this polymeric resins containing the functional groups of sulfonic acid and carboxylic acid, that should be the acid functional group contain having this hydrogen H plus proton, that should be exchanged with Na plus, Ca2 plus and Mg2 plus. Here this polymeric resin styrene divinyl benzene or amine formaldehyde copolymers containing quaternary ammonium groups having this OH minus ions or NH2 ions, that should be exchanged with, replaced with Cl minus, SO4 2 minus, HCO3 minus. So ion exchange technique having these two columns, one is having the cation exchanger column, another one is having the anion exchanger column. Cation exchanger column absorbs all the cations in the water sample, and then anion exchanger column absorbs all the anions in the water sample. The water coming out from this ion exchange having any ions, that is demineralized water. So this is an example for the adsorption process. Ion exchange process is used to purify the waters, that is removal of cations and anions present in the water. The water coming out from this ion exchanger is without any ions, that is cations and anions, that is called deionized water. So this is a cation exchanger and this is an anion exchanger. So this is packed with sulfonic acid and carboxylic acid functional groups, polymeric resins. This is packed with OH minus functional group, polymeric basic functional group, polymeric resins. So this is a cation exchanger and this is an anion exchanger. Here this water is input with this that is the water contains the cations and anions, that is hot water is coming inside, and this column is packed with cation exchanger, so that will absorb all the cations. Then the water is coming out and that will go into this another anion exchanger. This anion exchanger will absorb all the anions present in the water. Finally the water coming out from this both exchanger is having without any ions, that is deionized water. And this is the HCl container. It's used to regenerate the cation exchanger. This is the base, that is alkali, is used to regenerate the anion exchanger. So this is to exchange this anion exchanger, that is to increase the functional nature of this OH groups by using this alkali sodium hydroxide, to increase the that is H plus nature of the cation exchanger by using the HCl. So this is cation exchanger and anion exchanger. So reactions for this, what are the reactions will be takes place in the cation exchanger? So this is the cation exchanger RH2, and this is having the calcium salt and magnesium salt and sodium salts, calcium chloride, magnesium sulfate, sodium chloride. So this calcium chloride on reaction with this cation exchanger, this calcium is hydrogen is replaced with cation. This hydrogen is exchanged with this calcium, and the hydrogen and HCl is combined to eliminate as HCl. So this is retained in the column. So the calcium in the water sample that should be absorbed in the cation exchanger. Like that, when water is having the magnesium sulfate, means the magnesium ion is, the hot water is having the magnesium sulfate. The magnesium ion is absorbed with this cation exchanger. So this alkali, the magnesium is combined with alkyl group that should be retained in the column. So there is cation exchanger column that sulfonic acid SO4, that is sulfonic acid, that is sulfate ion, and H will give you the sulfonic acid. Like that, sodium chloride is present in the water. The sodium is replaced with this hydrogen, give this alkyl sodium, and then H and Cl eliminated as HCl. So these are the three reactions will be takes place in the cation exchanger column with respect to ions present in the water, that is calcium chloride, magnesium sulfate, and sodium chloride. Same like that in the case of in the anion exchanger, the anion exchanger is having this OH functional group in the anion exchanger. That is the water is having this anions, that is chlorine Cl minus and SO4 2 minus ions, sulfate ions and chloride ions, that should be replaced with this OH minus, that will give this RCl2 plus water, and also the same thing for this RSO4 plus water. So these are the reactions will be takes place in the anion exchanger column, and these are the reactions will be takes place in the cation exchanger column. So the cation exchanger will be exchanged and removed all the cations present in the water, that is calcium, magnesium and sodium. Anion exchanger will be replaced and should be retained or absorbed all the anions present in the water, that is Cl minus, SO4 minus in the water. So finally the water coming out from the both the exchanger is deionized water without any ions. So this next step is when the process will take place for a long time, so the cation exchanger and the anion exchanger will be exhausted. So that should be regenerated by using the cation exchangers should be regenerated by using this dilute acid HCl. The anion exchanger will be regenerated by using the dilute alkali sodium hydroxide. That means to increase the concentration of H plus ion in the cation exchanger, and also to increase the concentration of OH minus ion in the anion exchanger. For the reaction for this, how to regenerate this cation exchanger? So the calcium salt and the sodium salt of alkalis that should be treated with the HCl. Again, this formation of that is RH2 plus calcium chloride. So the RH2 is used as a cation exchanger. This RH2 and RH is used as a cation exchanger. Again, this column gets regenerated, that's filled with cation exchanger. So like that, RNA plus HCl will give RH plus NaCl. So it's like this in the case of anion exchanger, the chlorine ions present with the alkali that should be treated with sodium hydroxide. NaCl is eliminated, that's ROH minus functional group, that is anion exchanger is regenerated in the column. So this is called regenerative reactions, that is regenerative process. So this is the method to use for this water softening method. This method is called water softening method. That is hard water is converted into soft water by the removal of calcium, magnesium ions, calcium, magnesium, sodium ions by absorbing the cation exchanger, and then chlorine and sulfate ion by absorption in the anion exchanger. Finally, the water coming out from the both exchanger is having without any ions, that is called demineralized water or soft water. Next water softening method is zeolite method. Here the zeolite method is, zeolite is used for the adsorption. like cation exchanger and anion exchanger. Here we are using for this zeolite to absorb the ions present in the hard water producing ions present in the hardness producing ion present in the water. What is zeolite? Zeolite is nothing but sodium aluminum silicate. Sodium aluminum silicate, that is Na2O, Al2O3, X SiO2, Y H2O. So this is the formula of silicate. Silicate, when combined, and this is the diagram. For example, this is the zeolite bed. Zeolite bed, and then hard water is going inside. So this passing through this zeolite bed, all these hardness producing ions, for example calcium, magnesium, and then bicarbonates present in the water, that should be absorbed in the zeolite. The water coming out from this zeolite bed is having, without any hardness producing ions, is coming out as a soft water. So here, what is the reaction will be takes place in the zeolite bed is, here this sodium zeolite, the presence of calcium chloride and magnesium chloride is, so the zeolite is replaced with calcium. So zeolite is calcium, sodium is replaced with calcium zeolite. Calcium, sodium is replaced with calcium. So calcium zeolite, magnesium zeolite, that will give you sodium chloride. So this sodium is replaced with calcium and magnesium. Sodium is eliminated as sodium chloride, that will form the calcium zeolite and magnesium zeolite, that will be retained in the zeolite bed. So that is presence with the water containing the calcium and magnesium ions by adsorption of zeolite beds, that should be removed, and the water coming out from the soft water without any ions of calcium and magnesium. The same reaction for this calcium and magnesium present in the form of sulfates. Also here it is a chlorides, here it is a sulfates, also same reaction. So the sodium is replaced with calcium and magnesium, that will give the sodium sulfate. So water containing chlorides and sulfates of calcium and magnesium, so that should be absorbed in the zeolite bed. The zeolite bed, the water is coming out from this apparatus is having this without any ions of calcium and magnesium. So this zeolite, the process takes place for a long time. The complete this zeolite is that is calcium and sodium zeolites will be utilized for the removal of calcium and magnesium. Finally, the zeolite bed should be regenerated by using the sodium chloride solution, that is brine solution. Sodium chloride solution. What is regenerative reaction is, calcium zeolite is treated with sodium chloride, that is converted into sodium zeolite plus calcium chloride. Sodium zeolite and calcium chloride. This sodium zeolite again is used in this zeolite bed, used for the removal of that is calcium and magnesium in the form of chlorides and sulfates. So this is the zeolite method. Next water purification method is electrical demineralization of water. Here the electrical demineralization of water is used as ion exchange resins supported by paper or fiber. That should be used as a membrane for ion selective membranes. That is used as ion selective membrane for cation exchange membrane and anion exchange membrane. That should be nearest with this electrodes of cation, that is cathode and anode. Here this that is hard water is in the container, is having this both that is cations and anions, that is calcium, magnesium, and also chlorides and sulfates in the water that is fitted with the two electrodes, that is cathode and anode, and nearby this is a cation exchange membrane and anion exchange membrane. The cation exchange membrane will be exchanged the cations present in the water. For example, Mg plus, Mg2 plus, Ca2 plus present in the water that should be exchanged with this cation exchange. Cations will be absorbed by the cation exchange membranes. The anions will be absorbed by the anion exchange membranes, that is Cl minus, that is SO4 minus, etc. will be absorbed by the anion exchange membrane. The water present in the middle portion, it's having this without any ions, that is without any cations and anions, that is demineralized water. DM is nothing but demineralized water. So all the ions present in the water, that should be removed by using this cation exchange membrane and anion exchange membrane supported with this cathodes and anodes. So what is the application of using this cathodes and anodes? That will enhance, that speed up the process for the removal of ions, that is cations and anions present in the water. So this is the electrical demineralization of water using these ion selective membranes. So what is the application of ion exchangers for this? For the medical use, it should be excess salt, sodium salt present in the human body, that should be used, that should be removed by giving the suitable ion exchanger. For a person is having excess of sodium salt, for example, excess of sodium salt means you have to give suitable ion exchanger that should be reduce the sodium salt present in the body. And also another is the stomach is having acidity, high acidity. That high acidity should be removed by giving the weekly basic anion exchanger. Weekly basic anion exchanger that will remove the stomach acidity. And this is the excess sodium salt present in the having the person, that should be removed by the using suitable ion exchanger that will reduce the excess sodium salt. Next is how this activated carbon used to reduce the pollution, that is nothing but pollution abatement of air and wastewater. So there's two type of activated carbon is there. Activated carbon, one is granular activated carbon, another is powdered activated carbon. Powdered activated carbon means the carbon is in the form of powder, fine powders. So this is in the form of that is coarse particle, that is coarse, that is granular carbon. There are two methods is there in the granular activated carbon for the purification of air and water. One is the downflow fixed bed carbon contactors. Downflow fixed bed carbon contactor. Another one is B is off blow fixed bed carbon contractors. Downflow fixed bed carbon contractors is there are three columns is there, and the three columns is packed with carbon, that is granular activated carbon. So this water or air is passing downwards. First column, this is in series. The columns in series, this is in columns in parallel. The columns in series, this water is passed into the first column, second column and third column. Water is passed into the first column, and this that is ions or that is impurities present in the water is absorbed in the carbon, granular activated carbon present in the first column. Then again this water is coming out, again is passed into the second column. This is granular activated carbon present in the second column, absorbs the remaining impurities present in the air or water, and then it's coming out, it is passed into the third column. So this is the water or air enter into the first column, is seriously is going into the three different columns. So finally is coming out from the third column without any impurities present in the air and water. So this is the that is downflow fixed bed contactor. It is nothing but the three columns is placed in series. Here also same thing, the three columns is present in parallel. Here this water or air is going inside here first column, and then second column and third column parallelly, and also is coming out, is combined together, is coming out as a purified water or air. So this is in these two methods, and this is the highly advantageous method, because the same water is first the water or air is enter into the first column, again into the third column and second column and third column. So the same water entering into the three columns simultaneously. So that will leads to the adsorption of all the impurities present in the air and water. Finally the water is coming out from this third column is having without any impurities. Here but it is not like that. First the water is going into the first column, first water or air enter into the first column is coming out itself in the first column, but second column is separately taking the water and air is coming out into the second column separately, and third column separately taking into the water and air is coming out into the separately. All these combined together is coming out as a pure water. So here this purification is very less, here this purification is more. So this is called a downflow, because both these three columns water is entering into the downflow way. So this is, that's why it's called downflow fixed bed carbon contactors. The next one is off-flow fixed bed carbon contactor. So this is the off-flow method for using the fixed bed carbon contactor. Here this water or air or water is entering into the off-flow way. Here this first column is taking this air and water, and then coming out is entering into the second column, and third column is the out as a pure water. Here this is what is the difference between this downflow and the upflow? Because the downflow means the easily this is the carbon granular activated carbon present in the column gets filled with impurities, but here it will take long time. This impurities is filled with this granular activated carbon. So this is the application of granular activated carbon for the removal of for the removal of impurities present in the air and water. So next, this powdered activated carbon, how you can use for the removal of impurities from the air and wastewater. Here is this is the block diagram for this activated sludge process. Here this is a powdered activated carbon. This is polyelectrolyte storage. Here in this method, the powdered activated carbon is mixed with polyelectrolyte storage. That is both is mixed together. That will form a coagulant. That coagulant, here it is formed a contact aeration tank. It forms as a coagulant of both powdered activated carbon and this polyelectrolyte storage. And this here is the effluent. You are passing this effluent, that is water. That is effluent means that is impure water, and this going inside this aeration tank. And then this is the clarification tank. Here this coagulant, that's coagulant is nothing but this powdered activated carbon and this polyelectrolyte is mixed with this effluent and leaving for some time. That will settle the carbon. The powdered carbon will be settled. The remaining supernatant liquid of the settling of carbon and also impurities, the supernatant liquid and pure water is going inside here, and this is the filtration bed and filtered and removed as a treated water. Here is regeneration column is there. What is how you are collecting for this carbon is settled down. That carbon is separated here, and again it gets regenerated and passing into this column, this cycle, and you can use it for this coagulative process mixed with polyelectrolyte. This is nothing but carbon recycling process. Here this treated water is coming out from is having without any impurities. Here you can use the powdered activated carbon in the form of powder, that is fine powders. Normally resins is used for the polyelectrolyte storage. So this is the method to treatment of the effluent is coming out from the industries. So this is nothing but activated sludge process. So next is the application of activated carbon. So activated carbon is used as an adsorbent for the process of adsorption. So what are the different applications of activated carbon is? First one is it's water control. So water should be controlled. Water of the effluent should be controlled by the adsorption of activated carbon. For example, the effluent is having the hydrogen sulfide, that is rotten smell. It is bad smell. So that should be absorbed with this activated carbon. The water should be controlled by the adsorption of activated carbon. Next one is as a decolorant. Color should be removed by using the adsorption process. For sugar solutions is having the color and dye effluents. The effluent is coming out from the dye industries is having the colored. Color should be removed by process of adsorption. Second one is in solution purification. Using this column chromatographic techniques, the impure solution passing into these columns, the column adsorbs the impurities present in the solution. That the solution is coming out from the column is having without any impurities. The pure solution is coming out from the column. So this is also another adsorption process for the purification of water. purification of solutions. Next one is gas mask, toxic gases that should be adsorbed by using the activated carbon. And then air conditioning. In air conditioning, in large, that is auditoriums and big rooms, theaters having the odors, that should be adsorbed by using this activated carbon in air conditioners. And then industrial recovery. In industries, many industries, paper industries, dyeing industries, the effluent is coming out from this industrial process is having higher odor and also in higher colored solutions. That colored solution percolate into the land, that is here land, sand, and that well waters and lake waters that also converted into colored. So that should be removed by the adsorption process by using this industrial recovery process. And then cigarette filters, that is cigarette filters also is having the carbon, activated carbon, that should be filtered using as filters. Then removal of organic and inorganic matters. Organic matters, for example, phenolic compounds, derivatives of phenols. So this is phenols, and also derivatives of phenols, cresols present in the effluents and solutions. And then the inorganic compounds, for example, the trace quantities of there is calcium, magnesium, and then mercury, chromium, and then nickel, etc. present in the effluent, that should be removed by using the adsorption process by using the activated carbon. So these are the different applications of activated carbon used for different purposes.